Hello everyone. In this video, we are going to talk about the vector product or the cross product of two vectors. As the name says vector product, it means the result of the product is going to be a vector quantity having both the magnitude as well as the direction. So let's assume that you have a vector A bar with the components say A1, A2, A3 and vector B bar with the components B1, B2, B3. Then we find the cross product of vector A and vector B. First of all, you should know how to denote it. A bar cross B bar. Since the cross product, we use the notation cross. We find it as, again, there are two rules similar to the dot product. So when it is given in component, it is a determinant of the first row is the ijk, the unit vector along x, y, and z axis. Then, since your vector is A, the first vector is A, you write the components A1, A2, A3 as the second row, and next vector is B. So you write the component B1, B2, B3 as the third row. Now you will expand this determinant. How do we find that determinant? It is I. Now, we expanding it through the first row. So check I is the point of intersection of the first row and first column. So what we left with? We left with the term A2, B2, A3, B3. So it will be the determinant of it. Okay. Then moving to the next term. It's important to note that when we start expanding through first term, put the sign. It is plus, minus, and plus. Okay. Now, as we move to the next term, which is j, so we write with the j, the sign is minus, minus j. Now check. J is what? J is intersection of first row and second column. So what numbers we are left with? A1, B1, A3, B3. So writing down that here. It is determinant of A1, B1, A3, B3. Okay. Similarly, if we look for K, the sign is positive. What we will get? Yes, K is intersection of first row and the third column. So you will left with A1, B1, A2, B2. Clear? Because see, if I remove this, K is what? First row and the last third column. Okay, now when we are expanding this determinant, we basically cross multiply and put the sign of minus. It's always minus. Cross multiply, put the sign minus. Cross multiply the terms and put the sign of minus. So this give you I as A2 B3 minus B2 A3. It doesn't matter you write A3 B2 or B2 A3 because product is commutative. J as A1 B3 minus B1 A3. Similarly, with K, you will have A1 B2 minus A2 B1. Okay, so this is the cross product of vectors A and B. Note that unlike dot product, like if you find the dot product of A dot B or B dot A, it's same. Okay, this is for the dot product. But for cross product, if you find A cross B, it's not same as B cross A. Okay, it's not same, but instead it is the negative. Magnitude is same, but only the direction is different. B cross A. Because when you are finding B cross A, you are changing the rows. The second row become third and third become the second one. Okay, so it's better if you remember this property. Okay, now moving on to another way of finding the cross product, another way which includes the angle. So, if you have given the vector A, vector B, and theta, angle between A and B, the vector A and vector B, then you define the cross product of vector A and B as magnitude of A, magnitude of B. Now since angle is involved, for dot product we were having cos. Here we will have sine of angle theta. Okay, sine of angle theta. Remember sine of theta. Okay, this whole multiplied by n cap. N cap is nothing but a unit vector in the direction of A and B. So how it is, like how you will understand it, like if you have vector, suppose this is your vector u, this is your vector b, or let's use the name that we are using, A and B. Like you have this as vector A, this as say vector B, and say the angle between them is theta. Then the direction of A cross B is always perpendicular to both A and B. So this will be the direction of A cross B. Okay. Now, dot product we are using to find the projection of one vector on another vector. But the cross product we are using to find, say, area of parallelogram with parallelogram with two sides A and B. If the two consecutive sides of a parallelogram is A and B, then the area of parallelogram is given by magnitude of A bar cross B bar. Okay, we can also use the cross product to find the area of triangle. So if two consecutive sides are A, vector A and vector B, then area of triangle will be given by 1/2 of the magnitude of A bar cross B bar. Okay, another result that you need to know is two vectors are parallel if their cross product is 0. Okay, their cross product is 0, it means sine of theta is 0, right? Cross product 0 means sine of theta is 0. When it is 0, when theta is 0. So it means both A and B are in the same direction, same plane. Okay. So you need to remember these results when you are working with the vector product, okay, or cross product. So let's understand these things or practice these things with the help of these two definitions of vector product. So now here the vectors are given to you. They didn't involve the angle. So it means you have to use this definition of finding the cross product. So let's name our first vector as A bar, which is I minus 2j plus 2k, and vector B as 2i plus j minus 3k. So to finding the cross product, let's write the determinant. First column always I, j and k. Now first vector is A, so it is 1 minus 2, 2. Vector B, it's 2, 1 minus 3. Don't make a mistake over here, okay? So to avoid mistake, what you can do, here itself you write it in the component form. 1 minus 2, 2, and here as 2, 1 minus 3. So it's easier for you to work on it. So starting plus, minus, plus, I. So when you work with I, it's the intersection of first row and first column. So you left with determinant of minus 2, 1, 2, minus 3. Then minus j. What you have here? You have first row and the second column, giving you the numbers as 1, 2, 2, minus 3. Okay. And lastly, with k, what you have? 1, 2, and instead of second, you will have third column gone. So you left with minus 2, 1. Then cross multiply and minus. Okay, cross multiply and subtract, giving you I. So minus 2 times minus 3. Let me write it here. Minus 2 minus 3 minus of 2 multiply 1 minus j 1 multiply minus 3 minus of 2 multiply 2, and with k 1 multiply 1 minus of minus 2 multiply 2. Okay, better if you put it in a bracket to avoid any mistakes. So this gives you I. It is 6 minus 2 j minus 3 minus 4, and with k what you have 1 plus 4. So the cross product is 4i, this is minus 7 and this added with minus become plus 7j plus 5k. So this is your cross product for the given vectors. Okay. Now, if for the same question, they'll ask you find the area of parallelogram with sides A and B. Let me just rephrase this question. So yes, in the same question, what they ask, instead of finding the vector product, they said find the area of the parallelogram with sides this and this. Then you will be doing up to here exactly same. Now, here I have given you the result. The area of parallelogram is just the magnitude of cross product. So what you will be doing is, after this step, you will write area of parallelogram will be magnitude of A bar cross B bar. And you know how to find the magnitude. Write it in the component form 4, 7, 5. So this is root of 4 square plus 7 square plus 5 square. Just solve it. 16 plus 49 plus 25. It has to be a vector, a scalar quantity. So this comes out to be root of 90, which is approximately 9.49. So the area of parallelogram is 9.49. Okay. So this is the extra thing that you have to do. Now instead of area of parallelogram, if they say find the area of triangle. So what you have to do? You know that area of triangle. The formula is 1/2 of the magnitude of A cross B. So just divide this 9.49 over 2. You get the area of triangle. Okay. So in both the cases, you have to find the cross product. Okay. Now, next kind of question that they can ask you here is show that the vectors are parallel or show that the vectors are not parallel. So again, in this case, what you have to do is you have to check their cross product. So if A is 2i plus j minus 2k, in component form 2, 1 minus 2. Vector B, 2i plus 3j minus 3k. Okay, so in component form, this is 2, 3 minus 3. Find the cross product, A cross B. Doing in the same way, I, j, k, 2, 1 minus 2, 2, 3 minus 3. Now you know the process. So you'll get the result as, so as you get this vector as a non-zero vector, it is non-zero vector. So you will say that not parallel. Okay. It is possible to get parallel. Let's see another example. To check if these two vectors are parallel or not, writing the vector, let me say this is vector A, this is vector B. I'll write it in the component form as 5 minus 1, 1. This in the component form as minus 15, 3, minus 3. Finding the cross product. Remember, for parallel, cross product. For perpendicular, dot product. Okay? So don't miss this thing. I, j, k. This gives you 5 minus 1, 1 minus 15, 3 minus 3. Solving in the same way, what you will get I'm writing here directly 3 minus 3. J, you get minus 15 plus 15, and with k, if you do the calculation, you will get this 15 minus 15. So what you see, you get 0i minus, or you can write plus 0j plus 0k. So with 0 you can write either plus or minus, doesn't matter. So what you got? The cross product as a 0 vector. So this implies that these two vectors a bar and b bar are parallel. Okay. So how they can ask different questions? In this question, like instead of asking find the cross product, they may ask you find a vector perpendicular to the direction of these two vectors. So again, it means you have to find a cross product. Now, one important question. If they ask you find the angle between these two vectors, let's say this is vector A, this is vector B. You have to find the angle which is theta. Then you have studied the vector product as well as the dot product. So always go for dot product because this is easier. Okay, don't go for cross product. If you have a choice to go for select from vector dot product or scalar dot product or vector product, always go for this. Because in this case, what you have to do, you have the components 5 minus 1, 1. You have the component here minus 15, 3 minus 3. In both the rules, you need magnitude, correct? So, fine. Pi square plus minus 1 square plus 1 square. So this is 25 plus 1, 26 and 27. Magnitude of B minus 15 square, 3 square and then minus 3 square, which is 225 plus 9 plus 9, giving you root of, yes, 243. Okay, so you have magnitude of A, magnitude of B. This thing you have to do in both the rules, but finding the dot product is easier than the cross product because for cross product you have to solve this determinant, whereas for dot product it's simple. A bar dot B bar, just multiply the components. 5 times minus 15 plus minus 1 times 3 plus 1 times minus 3 and you are done. So how much is 5 times? This gives you minus 75 minus 3 minus 3. Add them. This is minus 78 minus 81. Okay, A bar dot B bar. Now using cosine of theta, which is A bar dot B bar, magnitude of A, magnitude of B. So this is minus 81 over root 27, root 243. When you are finding theta, it's simply the cosine inverse of minus 81 over root 27 root 243. Okay, and this you can get easily from your calculator. So selecting which rule to use, either the dot product or the cross product, also matters. It depends upon the question. When they didn't mention, they just ask you to find the angle, you can go for any one of the rule. It's always better to prefer the dot product when you're finding the angle because the components are given to you. Okay, I hope it's clear.